Hi, today we're going to do the PAT paper from 2012 looking at question 10. So question 10 asks us to sketch a function f of x that satisfies the following properties. A, that f of x is greater than 0 for all x. B, f of x is continuous. C, df by dx is 0 only for x equals 4. And D, d2f by dx squared is 0 for x equals 2 and x equals 6. Well, the first condition is simple. We simply just draw the axes from y equals 0 upwards and make sure that f of x doesn't cross the x-axis or touch the x-axis at any point. Now, f of x being continuous means essentially that you can draw it without taking your pen off the page. It means that there are no jumps or gaps in the function. So that's also quite easy. We can just draw that by having the pen never moving off the page. So we'll start drawing an axis on, and then we can start looking at part C and part D. So if we have our x and y axes here and here, what we do is we mark on our points. So we're concerned clearly with x equals 2, 4, and 6. So we're told that df by dx is 0 only for x equals 4. So we have a stationary point at x equals 4, but only at x equals 4. And well, because f of x is greater than 0 for all x, we must have that this is a minimum. So we can mark that on. So let's mark on a minimum at x equals 4. So there's going to be a stationary point there. Well, d2f by dx squared equals 0 means there's going to be a point of inflection, a change in curvature. What that looks like is, for example, if you had a cubic graph, a d2f by dx squared is when it flattens like this and goes up. So it's a change in curvature, a change in concavity. It goes from concave to convex. So that means we're going to have that at 6. So we're going to have something along the lines of this, but it's not going to be a stationary point, so it can't be flat. And we're going to have similarly at 2. But noting very carefully that it's not flat at 2 or 6 because the df by dx can't be 0 there. So what we literally draw is, well, we will redraw this to make it clearer, but we literally connect our points out. So we come down, we have a flat point at 4, and then we come down like this and have the same thing. And then literally we have f of x is going to be increasing from then on because there's going to be no stationary points other than x equals 4. So it just comes out like this. And that's an example of a function of f of x satisfying the properties.